Hello everyone, welcome to Artistic Atom channel. I'm Fatima and today we will continue our mass spectrometry session. Okay, this is our part 2 for mass spectrometry session. In this session, we will also discuss the exam oriented questions along with the topics which are associated with mass spectrometry. Now, firstly, we will be understanding how to predict structure using loss of neutral species. Well, this trick is the easiest one to follow, but sometimes it might not give you the exact results or the exact structures. Why? Because when we talk about neutral losses, these neutral losses are not at all different for the different structures. Why? Because when we have neutral losses, so it can be the possibility that I can see that there is a neutral loss of H2O. Now, this neutral loss can be for alcohol, can be for carboxylic acid. So, just by looking at the loss of this neutral species, I cannot predict what could be the probable structure. So always remember that neutral loss tells you what left. It will not at all give you the information where it came from. Okay, so always remember, do not follow neutral losses purely to determine the structures from the given spectrum. Now let us understand how to determine the structure from the given mass spectrum. Okay, so suppose in your exam you are provided with this particular structure and your task is to determine the structure or the compound for which this mass spectrum is given. Okay, so for this particular task, what you will do, you will follow these simple steps and you will determine the structure. So whenever we will be determining structure, the first step is always to determine the molecular ion peak. Okay, how you will determine the molecular ion peak? Well, you will look for the highest m by z value in the given spectrum. So I can see that in my spectrum the highest m by z value given is at 60. Now please note that this 60 has to be over here and this 45 has to be over here. This diagram is quite misprinted and I have taken this from the textbook itself. Okay, so please do note the corrections. Now, after I have determined the m by z value for my molecular ion, nextly I will look for the base peak. How you will determine the base peak from the mass spectrum? Well, you will look for the most intense peak in the mass spectrum. So I can see that here is the mass spectrum given, and inside this mass spectrum, I can see that only 31 is the m by z value, which is quite intense in the spectrum. So I will write it down over here as my base peak. Now, if I compare these two peaks, I can see that there is a difference of 29 molar mass. Okay, when I say 29 a loss of molar mass, what do you mean by it? This means this particular mass of species is being lost from my molecular ion. Okay, so what could be the possibility of this loss? So if I cross check with the table that I have shown you in the previous slide, I can see that M minus 29 loss can be due to C2H5 or CHO. Well, it is due to C2H5. The reason behind is why not of CHO? The reason behind is because this particular spectrum does not show any intense peak at 43. Why? Because 43 is the intense peak for ketones. So whenever you have carbonyl group present, then only you will be able to see CHO radical loss. Else it is not possible to see the CHO radical loss because it is very unstable. Hence, we can conclude that loss of C2H5 is observed in this particular spectrum. So we can conclude that we have molecular ion where there is loss of C2H5, and whatever is left, okay, whatever is the m by z value of this 31 can be of CH2OH radical cation. Now, on what basis I'm confirming that this 31 is due to the CH2OH radical cation? Well, it is because I can see that this peak is the most intense peak. This means this radical cation is the most stable. Since it is the most stable, that's why it is formed in the huge amount. Hence, it is giving that much intensity. And secondly, this is the characteristic peak for the primary alcohols, okay? Because when primary alcohols they get fragmented, they always results in the formation of this particular radical cation. And since this particular radical cation is very stable, that's why it gives the most intense peak at m by z 31. Please note this point because this is one of the most important point that will help you in solving the questions. Okay, so till now we have determined molecular ion peak. Secondly, we have determined base peak. Then we have determined the loss. And lastly, we have also gone through the characteristic peak for primary alcohols. Now, after we have done all these things, we have somewhat raw data available with us. Now, let us cross check everything, whether whatever we are thinking till now that it could be the probable spectrum for propane 1 all. Let us cross check it whether it is absolutely right or not. So how you will do the cross checking? Firstly, you will pen down the whole data that you have got. So when you have got the whole data, you will write it down over here. And let us check for the fragmentation. Okay, so you will carry out the fragmentation in the way we have learned in the previous session. Whenever you have a species with lone pair of electron, firstly you will carry out the ionization. Once you have carried out the ionization, this particular electron will be knocked off, which is loosely held. And then once it is knocked off, you will result in the formation of what? Radical cations. Then after you have formed radical cation, you will look for the alpha carbon, which is next to the radical cation. Okay, so after I have determined this alpha carbon, I will break the alpha bonds. Okay, so there are three possibilities of breaking alpha bonds. Two possibilities is of these two hydrogens, and another possibility is between these two carbon. So if you see that the most stability of the fragment will be between this when we break this particular bond. So you can see that here we have got this particular radical cation and this as the loss of neutral species. So this particular radical cation will give me the m by z value as 31, and I can clearly observe it in my spectrum. So this means I'm absolutely correct in determining the structure of uh, this particular spectrum which was given at the beginning. Okay, so this is how you will check for the structure or determining the structure from the given spectrum. Okay, now the question that might arise in your mind is that, ma'am, what about the other peaks? Okay, other than 31 and other than 60, I can still see that there is peak at 45, there is peak at 29, and even some more. So what about those peaks? From where those peaks are coming? Well, in previous session I have told you clearly that whenever fragmentation happens in a mass spectrometer, so during that fragmentation time, what happens? There are many possibilities, okay? But we only show the possibility where we are getting the most stable fragment, okay, for the primary fragmentation. But there are other possibilities also at the beginning, okay? But why we are not selecting them or why we do not show them? The reason behind is those radical cations are quite unstable. Since those radical cations are quite unstable, we do not show those fragments. Okay, so that's why. But see, those fragments will also be possible because we cannot control the fragmentation in the mass spectrometer. Okay, so it happens, but yes, their intensity will be very less in the mass spectrum. So as you can see that this was a possibility that we have discussed in the previous slide, and here's the another possibility that is possible. So if I break from here, I can see that here formation of CH3 radical or this radical cation, or there is other possibility also that you can take this CH3 cation and this as what? Radical. So if we follow these fragmentations, you can see that we can clearly get the m by z value of 45, and then we also get m by z value of 15, and we also get m by z value of 29. Since all these peaks are quite unstable, these carbocations are quite unstable compared to 31, hence their intensity will be less than that of this. Okay, but always remember that the characteristic peak for primary alcohol is at 31. Okay, this will help you in solving the questions. And since this particular CH3 radical cation is at m by z 15, and since this radical cation is very unstable, the possibility of this fragment will be least. Okay, Now let us solve a question to understand whatever we have learned till now. So the question is, which alcohol is likely to have a fragment ion at M by E is equals to 31 in its mass spectrum? Well, we have discussed it just now only, that if I open the structure of all the compounds given, I will get this whole data. Okay. So I have learned just now that whenever we have primary alcohols, they only give the most intense peak at 31. This means I just have to look for the primary alcohol. If you want, you can carry out the fragmentation and cross check your answer. But it is pretty sure that whenever we have primary alcohols, they give very intense peak at M by E is equals to 31. Okay, so I can see that the first structure given is my primary alcohol, second one is secondary alcohol, option C is tertiary alcohol, option D is secondary alcohol. So yes, from just by looking at the examples only, we can clearly see that option A is the correct answer for this particular question. If you want, you can carry out the fragmentation. I have also given you the hints how you will carry it out so that you can cross check your answers. Okay, once you are skilled at carrying out the fragmentation, nobody can stop you in determining the structure quickly. Okay, now, the next question is how to determine the isomers from the mass spectrum. Well, it is quite easy. So, suppose if you are provided with these two spectrums and consider that this data or about their name and the structure is not at all shared. So, at that time, how you will determine whether the given spectrums are of an isomer or not? So, well, it is quite simple. What you will do, firstly you will determine the molecular ion value. Okay, so I can see that in my first spectrum also it is at 60, and in my second spectrum also it is at 60. So in both the spectrum the molecular ion peak is at 60. This confirms that both the structures they have same molecular formula, but since the fragmentation pattern is quite different, they both show different peaks. This means their structure is different. Okay, but they have same molecular formula, which is a characteristic features of an isomer. Okay, so from this only you can conclude that the given spectrum is of an isomer. Okay, now here I have put one question for you. So if you have understood everything, you will be able to solve this question and predict the structure from the given spectrum. Okay, so do give it a try. Once you have tried it by yourself, here is the solution. So you can follow this solution and understand everything, how you're getting these peaks and how you can conclude that what could be the probable structure. Even I have shown you the whole fragmentation, how we will carry out the fragmentation. Okay, so do try it out by yourself. And now remember, there is an important point that for secondary alcohol, there is a characteristic peak at 45. Okay, along with this characteristic peak at 45, there will be loss of water as neutral species. Okay, so do check out these two things if you wanted to confirm whether the structure provided for the given spectrum is of secondary alcohol or not. Now, here is another question. Which pair of compound would you expect to both have a singly charged peak at M by Z is equals to 29 in the mass spectrum? This means here we are provided with these structures and we have to tell which one of the pair will have the M by Z peak at 29. So firstly, what we will do, we will draw their structures. So we have propane 1 all. So when I talk about propane 1 all, I can see that here is the structure. Okay, if I carry out the fragmentation according to the rules that we have learned, this is how the fragmentation will happen. And I can see that in case of propane 1 all, there is possibility of M by Z is equals to 29 peak. Okay, so since there is possibility of this peak, I can conclude that this could be the probable answer. So I can see that this propane 1 all is present in option A as well as in option D. This means I have to check for others also. So now let us check for propanol. Okay, so when we check for propanol, this is propanol. If we carry out the fragmentation according to the rules we have learned, I can see that there is also formation of this n by z is equals to 29. So this means this could be the other answer. So I have to check in which option they both are given together. So in option A only they are given together. So this means the correct answer for this particular question is option A. Now you can also check out the other options. I have shown you the fragmentation. You can check out those fragments and you will surely see that there is no possibility of m by z is equals to 29. Okay, there is quite overlap of my few figures. So uh, I just wanted to apologize for that. But yes, you can try it out and check that. Surely there is no presence of m by z is equals to 29 values for propane to all and propanone. Okay, you can check it by yourself. If you have any difficulty, you can ask in the comment section. Now another question, which of the ketones listed would not be expected to have a peak in its mass spectrum at m by e is equals to 57? Well, here also there is an important point. Okay, whenever I'm solving these questions, I'm sharing few tricks and tips so that you can use them in your exam to solve the questions. Now always remember that whenever we have any ketone, okay, and we are asked about the m by e is equals to 57. So always remember that m by e is equals to 57 value is the characteristic or the prominent peak whenever there is formation of this radical cation or this radical cation. Okay, and this is only possible in case of straight chain ketones. Okay, so this means if we have any branched chain ketone, there is no possibility of formation of this particular fragment. Okay, so out of all four options, I can see that only C option is the one where there is formation of a branched ketone. Okay, so if I carry out the fragmentation, I can see that they give fragments at what m by z is equal to 43 and m by z is equals to 71, which does not match with the data given in the question. So I can say that option C is the correct answer. Now after this, here I have put few of the characteristic peaks for few of the functional groups so that you can check. But yes, I will suggest you can use these tricks, but apart from these tricks, always make sure to cross check your answers by following the fragmentation pattern. These peaks will give you the hints, but fragmentation patterns will give you the confirmation. Okay, so you can see that here I have mentioned everything. You can go through it, and if you have any query, you can mention it in the comment section. I'll be really happy to help you out. This one is for the secondary alcohols and the carboxylic acid. This one is for the aldehyde and also this C2H5 radical cation. With this, we have completed our session. Thank you so much for watching. Do like, share, and subscribe to my channel, Artistic Atom. If you have any query, do mention it in the comment section. If you want me to make video on any specific topic, you can share that as well. I will try to make a video on that. See you in the next session.